All right, guys, let's get started. This is going to be a decimal review. So this first sheet you're looking at here, I'm going to take a picture of and upload it to Google Classroom. This page is just meant to summarize the big takeaways from lesson 1, 2, 3, 4, 5, and 6, which are the 6 lessons that we've learned. So the big takeaway in lesson 1 was to know that 1 whole is equal to 10 tenths, which is equal to 10 tenths, and I put it in unit form. And 1/10 is equal to 0.1. So when you write 1/10 in decimals, it's 0.1. And you could say this is 1/10. Now, the key takeaway for lesson 2 is that 1 whole plus 1/10 is equal to 1.1. Or 4 wholes plus 6 tenths is equal to 4.6. So here we introduced wholes by starting using ones and the tenths. So you have a 1, a decimal point, and a tenth. In lesson 3, we started thinking about how this works in terms of bundling. And we said if you bundle 10 tenths, you can make 1 whole. As I wrote here, 10 tenths can be bundled to make 1 whole. 6.42 would be 6 ones, because there are 6 whole numbers, 4 tenths, because we look here at the tenths place and there are 4, and 2 hundredths, because we look in the hundredths place and there are 2. In lesson 4, we said that 1 meter is equal to 100 centimeters. Therefore, 1/10 is equal to 10 centimeters. So 1/10 of a meter is equal to 10 centimeters, because 10 plus 10 plus 10 plus 10 plus 10 so forward would be 10 tenths, which would be 1 whole. You should also know that 1/100th is equal to 1 centimeter. If you think about it, by looking at this little model I made, if this whole thing equals a meter, one of these squares would be a tenth, and one of these tiny little lines would be a hundredth. The big takeaway for lesson 5 was that you can multiply and divide by showing it into models. So you can multiply 1/10 times 10 to make 10 hundredths. You can also divide 10 hundredths by tenth to make 1/10. And that is why 10 hundredths is the same as 1/10. And we can see that by looking at this model. Let me bring it a little closer, where we have tenths and hundredths. And if I fill in 1/10, it is the same amount as if I fill in 10 hundredths. So if you're able to show me that, you're on a great track. And then in lesson 6, we kind of introduced wholes with or ones with tenths and hundredths. For example, in this number, you should now be able to tell me that there are 6 ones or 6 wholes, 4 tenths, because that's in the tenths place, and 8 hundredths. So if I were to tell you, place this on a place value chart for me, you should be able to tell me that there are 6 ones. And then don't forget to bring down your decimal, because that friend always lives here. It's always going to live between the ones and the tenths. You have 4 tenths, which is the next place value over, and you have 8 hundredths. So that's how you would plot it. So this first page is just really here to tell you what all your key takeaways are. And if you understood everything I talked about here, you should be pretty set to do well on tomorrow's mini test, okay? And also remember, there will be some eggs in between the video. The first egg is going to be Elsa. Go ahead and write in Elsa for the first egg, okay? Now, there is going to be some review sheets that we're going to go over. And here is the first review sheet. The first thing we learned were tenths. Tenths. And tenth is the first number over after a decimal. So if you see a decimal, the number right after will be a tenth. And I can show you how a tenth works, because the tenths, so 1/10 is the same as 0.1. So this 1/10 is the same as 0.1, 2/10 is the same as 0.2, 3/10 is the same as 0.3, 4/10 is the same as 0.4, 5/10 is the same as 0.5, 6/10 is the same as 0.6, 0.7, 0.8, 0.9, and 1 whole, because 10 over 10 is 1 whole. So this is just one way to see it in a tape diagram or area model, and it would work the same way in a number line. If you were to label a number line into tenths, you would start at 0 and end at 1, and you would have 0 tenths, 1 tenth, 2 tenths, 3 tenths, and here you see it backwards. So here you see the fraction and then the decimal. Here you have the decimal and then the unit form of it. Now, knowing what we know and knowing that in order to make 1 whole, you need to have 10 tenths, let's fill these out together. So you know that 8 tenths plus is going to equal to 1 centimeter. So think about what that is. Give you a couple seconds. Your answer should have been 2 tenths centimeter, because 8 plus 2 is 10, and 10 over 10 is 1 whole. Now, 2 tenths centimeter plus something would equal to 1 centimeter. Again, how do we get 10 over 10? Remember, when we add fractions, you don't really add the bottom, you just have to have the same denominator. So you need 8 tenths centimeter for this one. And then finally, if we had 6 tenths, so imagine that I had colored all the way to 6 tenths, how many more do I need to get to 1 full centimeter, or 1 whole, which would be at the end? So it would be 1 tenth, 2 tenths, 3 tenths, and 4 tenths that I would color. That's why this answer makes sense. Now, remember, now we know 8 plus 2 is equal to 10, so 10 tenths equals to 1, yep. 2 tenths plus 8 tenths is equal to 10 tenths, which is equal to 1, yes. And then 6 tenths plus 4 tenths is equal to 10 tenths, which is equal to 1. Awesome. So now I'm going to turn these numbers into decimals, just so that we look at it for the first time. Or hopefully not the first time, but for the first time in the review. So 2 tenths as a decimal would be 0.2. 8 tenths as a decimal would be 0.8. And that's because tenths is the first place value after the decimal. 4 tenths as a decimal would be 0.4. So that is how you would do that. Now, say that I asked you to plot the number 6 tenths plus 2 tenths. You would go plus 1, 2, 3, 4, 5, 6. So that's plus 6 tenths. That's where you should start off. Plus 2 tenths. I'm going to jump 1, 2 tenths plus 2 tenths. So 6 plus 2, you end up at 0.8, which is equal to 8 tenths. And you would have known that just by adding across. And I just showed you why this makes sense with decimals too. So these are tenths, and we spent the first 3 lessons on this, so I hope you're good on this. Moving on to hundredths. So let's look here. If we had this in hundredths, if we had an area model with hundredths, it would look like this: 10 hundredths, 20 hundredths, 30 hundredths, 40 hundredths, and so on and so forth, until you made 1 whole at 100 hundredths. And the reason I made this model was because I didn't really want to make 100 little pieces on the inside. But I can show you a little better what I mean with hundredths in this little bottom number line. So here, yes, it's in hundredths, but remember, 10 over 100th would be the same as 1/10, because if I were to shade this number in, I would have shaded 1 out of 10 boxes. So 10 over 100 is equal to 1/10. 20 over 100 will be equal to 2/10, and so on and so forth. Now, if we're thinking of hundredths, you are no longer just looking at the 0.1s. Now, you are thinking of the little tiny 10 pieces that lie in between. So 1/100th would be right there on that first little pink line. The reason for that is that in this number line that goes from 0 to 1, each pink line represents 1/100th, while each gray line that's going down like this is representing 1/10. Like it says here, note here, the hundredths are the little pink lines because there are 101 whole. So if we look back here at the one we just did, there are only tenths. We don't see the hundredths yet, right? So you're imagining, for example, 10-cent coins here. Now we don't have 10-cent coins. Now we have pennies. That's why it's so important that I have 100 of them to be able to make one whole dollar. So let's see how that would work if we were going to turn this, if you're giving a fraction, or if I give you a fraction, how do you turn that into a decimal? Well, this is where you may be a little bit confused, which is okay. If you think about it, say you have 28 over 100, this will be 0.28. Now you're thinking, but Miss Leon, isn't this the tenths place? Yes, it is. But in 28, we can make 2/10, and let me show you why. Because if I'm gonna draw this as place value discs on this one only, if I have 28 hundredths, I would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Awesome. I can bundle 10 and voila. And I can bundle 10 and voila. Now I have 8 left over at the end, 2 here, and I have 0 ones. So now I still have 0.28, okay? So my answer here is 0.28. 28 hundredths would be written as 0.28. Same thing goes for 77 hundredths. It would be 0.77, and I'm not going to draw 77 dots, but if I did, you know that I would bundle 7 and move them to the tenths. I would make 7 bundles and move them to the tenths, because with 70 you can make 7 bundles. And then I would have that 7 here, and I would have 7 left over here. Still no ones, so this would be 0.77. Remember, don't forget to bring our friend the decimal down. Next one, 94 over 100. So if I were to put 94 dots in here, I can make 9 groups of 10 and move 9 over into the tenths place. So now there would be 9, and there would be 4 left over that I didn't bundle. Decimal comes down, 0.94. Now 62 over 100, or 62 hundredths. If I were to draw 62 dots for you here, I would be able to bundle 6 groups into the tenths, and I would have 2 lonely friends left over that did not fit into a bundle, and bring down the decimal. So that is how we learn hundredths. And now you know there is the tenths that you have learned and the hundredths that you have learned. Okay, so the second egg for your answers is going to be Olaf. Olaf. All right, now moving on to mixed decimals. So if you think back to mixed numbers, it was when you had wholes and fractions together. So it's going to be the same thing for mixed decimals. Excuse my hands, I made these sheets and I get all dirty. So you're going to make them into decimals. Mixed decimals means that there will be more than one whole. So we will have a whole. So these are mixed numbers. This is 1 and 28 100ths. So the only thing that changes here is that now you have something before your decimal. And you know you're going to have 1 before the decimal. And if I go down the list, I already know that I'm going to have 3 before the decimal, 7 before the decimal because there are 7 wholes, 7 before the decimal because there are 7 wholes, 3 before the decimal because there are 3 wholes, and 9 before the decimals because there are 9 wholes. Now, let's get to work with the tenths and the hundredths. So these look like most of them are hundredths. I do have a 10 here, don't miss it. But say here it says 28 over 100. So if I were to put 28 here, I know I would make 2 bundles. That would move over here. And I would have 8 left over. I have my decimal point, and I knew there were 1 ones. So 1.28. And you're going to think the same way all the way down. 46 over 100 has 4 tenths and 6 4/10ths, because if I put 46 dots here, I would move over 4 bundles. It would have 6 left over that did not fit in my bundles of 10, and there were 3 holes. So this would be 3.46. And you start to see a pattern where it's 1.28, 3.46. You're seeing it. Now, here you have tenths, and don't be tricked by this. If there are tenths here, that means that this will be in the tenths place. So the tenths place, as you guys should know, is right after the decimal point. So I will put this guy in the tenths place, bring down my decimal point, and bring down my holes, which were 7. And I don't have anything here. You can put a 0, and if that makes you happier, you could leave it blank. It means the same thing. Now I have 0.3 over 100. Now I have it in the hundredths place. Now it's out of 100. So if I only had 3 hundredths, I would put him in the hundredths. And it doesn't look like I have any tenths. So then the 0 would be here. And I still have exactly 7 holes. So it would be 7.03. Now let's move on to this one. 41 over 100, and I had 3 holes. I already wrote them in here. I'm going to bring them to my ones. I have 4 bundles that I would move into the tenths, and I have that 100th left over. Here's my decimal point. Last one here. Now I have 9 point something. You know there are 9 holes. And you have 64, so if I had 64 hundredths or 64 dots here, I could move over 6 groups of 10, and I would have 4 left over, 9.64. Pretty straightforward. Go ahead and rewatch, pause, rewind as you need, but you should be all good with this. I know I saw the work and we looked good. So one thing that I noticed is a little bit of a hassle for us is expanding or expanded form. So let's expand these numbers into decimal form and fraction form, okay? So I kind of messed that up. So this is actually going to be 3.92 up here. And this is going to be 7 and 26 100ths. Sorry, I put them in the wrong place. Okay, so if we were to expand 7.26, this is how I want you to think about it. We can expand this into the 3 different place values that they have. So there's ones, and to make ones, you need a 1 times 7. Awesome. Now you have tenths. To make that tenth, you need a tenth times something, and 0.1 times 2 would give you 0.2. Plus, now you have hundredths. Hundredths you write like this, and to get 0.06, because now you're only thinking of that place, you would multiply by 6. So that is how you expand with decimal form. Let's do one more example with 3.92. 3.92. Now there are ones place, so I'm going to expand that with the ones place. That's 1 times 3 plus the tenths place, which should be 0.1 times 9, and then plus the hundredths place, which should be 0.01 times 2, because 1 times 7 gives you 7, 0.1 times 2 gives you 0.2, 0.01 times 6 gives you 0.06. If you add these together, it would give you that answer. Same thing for the bottom one. Now for fraction form. Fraction form's a little bit different, but not really. If you have the fraction 7 and 26 over 100, what you want to do is 7 times 1, because that will give you 7 wholes. Then you want to do 1/10 times 2 because that will give you 2/10. And then you will do 1/100 times 6 because that will give you 6/100. 2/10 is the same as 20/100. Add it all together, this would be 7 and 26/100. I know the fraction form's a little bit more confusing, but all you're doing is you are using a fractional unit for the tenths, a fractional unit for the hundredths. I will also accept if you use hundredths for both, so let me show you what that would look like with this one. 3 and 92 over 100 is the same as, oh, let me put these plus marks, 3 times 1 because that's equal to 3, and then I would do 90 over 100, 10 over 100, 1 over 100 times 92 because that's still technically giving me the fractional form of it. If you're super confused about fractional form and decimal form expansion, this is what I'm going to focus on during office hours today. So go ahead and come, okay? Third egg is going to be Sven. Sven. Clearly, I am going with a Frozen theme here. So, in order to be prepared for tomorrow's test, you need to know how to represent tenths, hundredths, and mixed fractions into models if I give you a number. In order to be successful in tomorrow's test, you will need to know how to plot. So if I give you a tenth, a hundred, or a mixed fraction, you should be able to plot it on a number line. You should be able to decompose by units or expand, such as what I kind of just showed, and filling a chart. And this is the last example I'll go over in this video. So it will give you, for example, something like this, and you'll fill in the rest, or they'll give you this one and you'll fill in the rest, and let's see how we would do that. So if there are 6 ones, that's 6 wholes, and I'm doing fraction. 6 wholes, 2/10, and 4/100, I know I can write it like this. Awesome, super easy, super fast. 6 and 24/100, yay, one more example of fraction expansion. It's the same as 6 times 1 plus 1/10 times 2, because there are 2/10 here, plus 1/100 times 4. Okay, all I did was take a fractional unit for the tenths, a fractional unit for the hundredths, and I multiplied it by that number. Now finally, in decimal expanded form, 6 and 24 over 100 would be 6.24. Let me put that at the end because here's where you'll write the decimal, and let me expand that for you. 6 times 1, obviously, that will give us 6, plus 0.1 times 2, because that is the tenths place, and finally, plus 0.01 times 4. So don't get super nervous. I know that this looks a little bit difficult, but it is the super high level goal of this. So if you still have questions about this, again, come to office hours. I will go over this again and again and again. And we will go through some examples so that I know that you are all set for success on your mini test on Friday. And the fourth egg will be Arendelle. Arendelle. So go ahead and type in the 4 eggs into where you would usually submit your problem set, and you will get full credit. Thank you for watching.